Physical Science Exam 2015, question 5. Part A. Nylon ropes that stretch are used in rock climbing. Rock climbers attach themselves to the steep cliffs by means of these nylon ropes. So there you go, from there to there. If a rock climber loses his grip on the rock, he will begin to fall. His fall will be stopped by the rope. Use the law of conservation of momentum or one of Newton's laws to explain the advantage of using a stretchy nylon rope compared with a rope that does not stretch. Okay, so this is the crux of the matter. And it's worth 3 marks. So you'd want to be making sure that you use either the law of conservation of momentum, and I think we'll use Newton's laws, to explain the advantage of a stretchy rope. So, when he's up here, his initial velocity is going to be equal to 0. When he lets go, his velocity is going to increase. As he free falls, the rope will be all slack. The free falls until he gets to a certain downward velocity. And let's call that velocity u, because that's when we really start to be interested in. At the point that this rope starts to get tight. Because after that, after the stretch in this rope starts to take up the slack, he will come down here until such time as the velocity is equal to 0, because that's what the rope's going to do. Now, the time he is going to do that is going to be a change in time from u, his velocity going from u, to his velocity going to v. So, the falling climber goes from a downward velocity u to v equals 0 in time. We'll call that delta t, because that means change in t. So the force stopping the climber, therefore, the force stopping the climber is equal to F equal to, let's have a look at our, so force is equal to mass times acceleration, or the force is equal to the mass times v minus u on change in t, which is exactly what we've got here. That's why I use change in t. So the mass times v minus u in change in t. So the force that he will strike the climber, the mass is not going to change. The final velocity is equal to 0, so that's not going to change. The initial velocity at this point, regardless of whether it's a stretchy rope or a non-stretchy rope, is going to be u, so that's not going to change. The only thing in this equation that's going to change is the amount of time. With a stretchy rope, delta t is increased, and therefore F is decreased, because if delta t is increased and this is the same, that's going to make that a smaller number, because delta t is under the is in the denominator of this equation. Less force on climber will do less damage, and that is due to Newton's second law. Force equals mass times acceleration. 3 marks, no problem. In baseball, players are encouraged to follow through when hitting a ball. This increases the time of contact between the bat and the ball, compared with when the player does not follow through. Use physics principles to explain the advantage achieved by following through, assuming the forces are the same in each case. Well, in this case, it's going to be the same as we have up here. Force equals mv minus u on A. So this is going to be the force that's applied to the ball. So the initial velocity of the ball is not going to change. The final velocity of the ball, oh, that's not meant to be A either. Look, I made a mistake there. I hope you all saw that and were yelling out at me. That's not A at all, it's delta T. Force equals L on delta T. So going back, the forces in baseball, players are encouraged to flow through and hitting the ball. So the ball, its initial velocity is going to be going u in that direction, and the final velocity is going to be v in that direction. The mass of the ball is not going to change. Again, since m v, well, actually velocity will change. M and u do not change, then increasing delta t, or the time, what is that going to do? That's going to increase so what we end up doing here is, by increasing, well, just increasing the time with the same force, since the if you're hitting with the same force, okay, then increasing the time means that if you multiply through by, you get f times delta t is equal to mv minus u. Then what we have here, since that is the same and that is the same, and over here the force is the same, by increasing means that the velocity also increases. Newton's second law. And by this case, because as the force of the batter is coming through is going to be the same, the mass is the same, the initial velocity is the same. If this one is going up, then this one must also be going up. So what we have there is also increases, increased velocity means increased range. Again, another 3 marks.